labeling principle. Avoid long arbitrary sequences. Do not require users to know the absolute position of an item in a list. Instead, associate meaningful labels with arbitrarily ordered items. In generally, we can say use symbolic names instead of memory addresses or line numbers to associate with programming elements such as subroutines, variables, or operations. We will consider about an example. We used web addresses rather than IP addresses for website accessing purpose. Why is that? It's very hard to remember an IP address. So we use a web address to access some particular website. It's easy and time consuming. Though the situation is like that, there are some violations for programming languages with this principle. Violation of the principle by the programming languages. Numeric operations in IBM 650 pseudocode are non-descriptive. Now we will move on to the next principle, regularity principle. Regular rules without exceptions are easier to learn, use, describe and implement. In generally, we can say there should not exist any exceptions to grammar rules. Consider about this example. If a semicolon denotes the end of a line, it should be required after every statement. Are you remember when we were in first year as undergraduates? We got lots of errors when we were doing C++ programming. When we were doing coding using C++ programming. Why is that? Is it possible to get such a kind of errors? Yes, it's because of this missing of semicolon. So, it is necessary to use these regularity principles in order to avoid errors. But FORTRAN, Pascal as well as C violate this principle, regularity principle. Violations of the principle by the programming languages. FORTRAN can store strings in integers. In FORTRAN, there is no type checking mechanism. So, if we get an error, it is difficult to catch it. Pascal, use of semicolon after a block statement is optional. We can either use or we don't. As well as in C, use of semicolon after a do-while loop, use of semicolon after structs. Now we will move on to the next principle, preservation of information principle. The language should allow the representation of information that user might know and the compiler might need. In generally, we can say when we are doing coding, it should be done to give only the information needed and necessary. To get some idea, consider about this example. The method of parameter parsing used in subprograms is an often ability of languages to allow users to choose the side effects that are active to the action of the submodule. This is the best example to say that FORTRAN compiles with the programming languages, since the do-while loops using FORTRAN compiles with the preservation of information principle. Though the situation is like that, C arrays as well as Perl arrays violate this principle, preservation of information principle. Violations of the principle by the programming language. C arrays can become pointers when returned from a function. Perl arrays use identifiers when passed into a subroutine. Now we will move on to the next principle, orthogonality principle. Independent functions should be controlled by independent mechanisms. In generally, we can say, let all combinations of a small set of primitives be legal, because even a small set of primitives lead to a large number of combinations. Too much orthogonality reduces simplicity. As an example, Algol 68 did this and can make absolutes in the code difficult for compiler to detect. Consider about this example. In a traffic light system, have checked minimum number of lights, red, yellow and green, to fulfill its all duties. Why is that? It says we should use minimum number of requirements to do a task, and if we can combine resources, we should do it in order to avoid wastage. But C violate this orthogonality principle. Violations of the principle by the programming languages. C functions can return records but not arrays. Records cannot hold void members or members of their own type. Arrays cannot hold voids or functions. Arrays are passed by reference, whereas everything else is passed by value, pointer arithmetic. Now we will consider about the next principle, simplicity principle. The language should be as simple as possible. There should be a small number of concepts and simple rules for their combinations. Avoid multiplicity. In generally, we can say the language which we use should be simple as possible. It's because to increase readability and writability. Think this example. Think a situation have 20 different styles to write a particular program and programmer knows 5 out of 20. What happened to readability? What will happen to writability? Both will reduce. Though the situation is like this, most of the programming languages violate this simplicity principle. Violations of the principle by the programming language. Most of the programming languages use same operators for number increment. See this example. You will get a better understanding about how this violation will happen. Now we will move on to the next principle, impossible error principle. Making errors impossible to commit is preferable to detecting them after they are commissioned. In generally, we can say errors should be detected. As an example, there are lots of error checking mechanisms with modern programming languages. Though the situation is like that, There are some violations with FORTRAN for this impossible error principle. Violations of the principle by the programming language. In FORTRAN, there is no error checking and exception handling mechanism. With that, we discussed about more principles in detail and how those principles violate the programming languages. As IT undergraduates, we should have a rough idea about that programming languages and how those are tackled with the programming languages. Now we will consider some more principles, but not in detail. In brief, what is the principle? The automation principle. Automate mechanical tedious or error-prone activities. The next principle, localized cost principle. Users should only pay for what they use. Avoid distributed costs. The next principle, manifest interface. All interfaces should be apparent in the syntax. The next principle, portability principle. Avoid features or facilities that are dependent on a particular machine or a small class of machines. The eligency principle. Confine your attention to designs that look good because they are good. The last one, security principle. No program that violates the definition of the language or its own intended structure should escape detection. So with assignment part 1 and assignment part 2, we discussed lots of principles and how they tackle with programming languages, how they violate these programming languages. As IT undergraduates, we have to have a rough idea about these principles. To the best of our knowledge, we think this video will be beneficial to you all. So, see this and get a maximum output from this to enhance your knowledge. And also, thank you very much for everyone who support us to finish this video and support us to give a valid output. Thank you very much for our lecture in charge, our assistant lecturer, and our friends, dear parents, and to everyone. Thank you very much for your